we can continue now with Maria Borysenko's presentation. She's from University of Chemistry and Technology in Prague, and she's a PA student at the Department of Chemical Technology of Monument Conservation, and she also works as a conservator restorer at the Museum of East Bohemian in Hradec Králové. And today she will talk us about nanocellulose in restoration. So the floor is yours.
Oh, thank you. I need to admit that previous presentation was fantastic. So I will support girls by black and white style. And also I will speak more. They mentioned about tracing paper, and now we will speak a bit more about tracing paper and the problems and techniques or materials which we can use due our conservation treatments. So, carrying out conservation restoration treatments on objects with transparent or very thin support, such as tracing paper, films, or very thin paper, presents a number of challenges, one of which is the reinforcement of tears. I think that paper conservators know this problem very well. For the aforementioned collections, this process requires not only providing the necessary physical strength and compatibility of the filling materials, but also maintaining the essential visual aspect, sufficient transparency to ensure that the reinforcement areas don't compromise the aesthetic integrity of the artwork or its legibility. One of the transparent support is tracing paper, a material that has been used for centuries, including for the imitation of parchment. Since the 1860s, tracing paper became widespread material due to its properties: transparency, smooth surface, versatility in artistic and printing techniques applicable to its support, and the possibility of production large sheets. It was used by artists, architects, engineers, designers, tailors, bookbinders, and other professionals. Additionally, this material was used for the production of high-quality envelopes and packaging. And here you can see the example of tracing paper, which was used to transfer the ornament or decoration to the book. So this is, I think that paper conservators know that different tracing paper, they have their different damages, which dedicated of their use. For example, architectural drawings or plans, they have the typical damages. And for example, this object, it's a drawing which were made by bookbinders. It have its own typical damages. Back to the topic. So one of the history left a significant number of the objects on tracing paper, which are preserved in numerous collections with archives, libraries, museums, and galleries. Consequently, the issue of the restoration remains highly relevant. Worldwide, this topic has been studied by researchers such as Claude Larocque, Hildegarda Homburger, Barbara Korbel, Verena Flam, Diana van der Reyden, Christina Hoffman, Mary Bacon, and others. And in Czech Republic, works on tracing paper restoration have been published by Dominika Murovceva, Veronika Kopecka, Alena Hurtova, Daniela Volkova, and Anna Ptačková. And if we will make analysis of Czech experience in Czech restoration practice, Japanese paper is commonly used for tear reinforcement. As adhesive cellulose ethers, such as Clucel G and Chilosa, are widely applied, as well as isinglass and starch paste. In publication mentioned such materials as Filmoplast R, Archiboard tissue. Archiboard tissue, it's 100% hemp tissue coated with layer of paralloid, and BEVA 371 are mentioned. It should be noted that the selection of adhesives is necessary issue as each adhesive has specific characteristic that must be taken into account when developing a methodology for restoration of artworks. For example, Glutzel G may attend yellow color over time in some cases. And according to studies on its degradation, Filmoplast R, after 4 years of storage in the dark, shows shift of pH to 8.35. When an appropriate restoration methodology is applied for the materials are used correctly, the aforementioned adhesives allow conservation specialists to successfully achieve their goals and carry out high-quality restoration. Nanotechnologies are used in the field of conservation in various directions. For example, the use of inorganic nanomaterials can improve the mechanical and aesthetic properties of objects, protect collection from acid or ultraviolet degradation, prevent biodeterioration caused by fungi or bacteria, etc. These findings open a promising avenue for further research and development of nanotechnologies in the field of conservation. Here I will speak about nanocellulose for the restoration of tracing paper, but it should be noted that the described method can be also applied for other transparent and thin bases, such as cellulose acetate films or thin paper. The first nanocellulose suspensions were obtained using a method developed in 1977 by researchers at Eastern Research Division of IIT Ryanair in Whippany, New Jersey. The research group repeatedly passed diluted wood cellulose pulp through the Menton Gallion 15 mR milk homogenizer, producing a semi-transparent gel. You can see the picture how it was look like. This new structure was named microfibrillated cellulose, MFC, as the mechanical treatment disrupted the fiber structure, allowing the release and formatting of microfibrils. Over the years, a number of procedures have been developed worldwide for the lamination of fibers with wood consistently being the primary source of producing microfibrillated cellulose. Today, the use of nanocellulose is widespread in various fields, including medicine and the food industry and electronics. It is also used as a biological alternative to replace plastic films and petroleum-based products. The first studies on the use of nanocellulose as material for restoration began in France in 2014. And since then, the application of this technology has emerged as a new direction in the restoration of cultural heritage objects. In paper restoration, 3 types of nanocellulose and their composites can be used for a variety of processes. There are studies in their application for deacidification, straightening, consolidation, antioxidation, enhancement of UV resistance, cleaning, reduction of air permeability, and flame retendency. Specifically, these include bacterial nanocellulose, B and C, the previously mentioned microfibrillated cellulose, MFC, and cellulose nanocrystal, C and C. Different technological methods are applied to produce each type, which in turn affects their properties. A nanocellulose-based product in the form of film is referred as a nanopaper or nanofilm. The transparency and high mechanical strength of nanocellulose film open new possibilities in paper restoration, particularly in situations where the use of Japanese paper doesn't provide the desired results for conservator. MFC film can effectively transmit light, allowing them to be made as transparent as polyester films such as Melinex. CNC films are even more transparent than MFC films. However, their mechanical strength is lower due to the fact that they consist solely of crystalline cellulose regions. And BNC also exhibits excellent transparency as it is composed of the pure cellulose with minimal impurities of amorphous regions and has high degree of crystallinity. Nanofilms may be slightly visible under transmitted light when used in the restoration or artifacts, but they are almost imperceptible in the direct light. Both MFC and BNC films also demonstrate high mechanical strength. Nanocellulose films are made from pure cellulose, have a pH close to 7. Studies shown that they are resistant to degradation caused by light, temperature, and heat, which are crystal stability criteria for material used in the conservation in the conservation of artworks. Okay. There are various approaches to preparing nanofilms, including the addition of additives or dyes, which can be used to tone the final product, provide matte or glossy finishes if desired, or modify mechanical properties. In general, 3 main methods are used for the production of nanocellulose films. Manual method requires a laboratory press for forming films with controlled temperature and pressure. Filtration method and casting with subsequent drying. The last method, casting with subsequent drying, has been recognized as optimal based on previous studies, as it is always for the production of homogeneous films through a simple laboratory procedure. The process of producing nanofilms can be casting with subsequent drying includes the following steps. The suspension is first prepared by stirring on a magnetic stirrer, after which it is poured into a petri dish and left to air dry. It took something near 5 days to dry totally. Casting nanocellulose film with a content of 0.1% by mass or less is not recommended, as this results in excessively thin film that is unsuitable for use. For convenience, suspensions with concentration of 0.3 till 3%, depending on the type of nanocellulose, are poured into polyester or silicone petri dishes or Teflon trays, facilitating easier removal of the film after drying without damage. Before casting, methyl cellulose can be added to the suspension if it is necessary. This improves the integrity and mechanical strength of the nanofilm, increases transparency, and facilitates its removal from the petri dish. Additionally, the suspension can be toned with watercolor colors prior to casting to achieve the desired shade of the final product. It should be noted that pre-prepared CNC suspension made slightly yellow or display interference colors or iridescent shades. In such cases, if it has happened, it's recommended to use a CNC in the form of dry powder provided by the manufacturer. Due to their small fiber size, nanopaper fibers are highly hygroscopic. It makes them sensitive to moisture. When water or water-based adhesive are applied to the surface, the nanofilm loses shape stability. Additionally, during subsequent drying, nanocellulose film may shrink, casting planar deformation. Nevertheless, studies on the use of nanofilms are as supports with surface-applied adhesives that are activated by moisture or ethanol following expansions and shrinking tests have demonstrated the practical applicability of nanofilms with gelatin or methyl cellulose. For conservators, the ability to select different adhesives based on the characteristic of the objects under restoration is crucial. The variability in adhesive choice also expands the potential application of nanocellulose films in restoration. Accordingly, nanofilms are used with various adhesives activated by ethanol or heat, such as Klucel-G or Aquazole. One method for tracing paper restoration involves the careful application of Aquazole in ethanol into the nanofilm surface, followed by heat activation of the adhesive during tear reinforcement. Aquazole is widely used in conservation as an adhesive consolidant, as an interlayer barrier. In conclusion, it can be stated that nanomaterials in conservation represents a perspective direction, enabling the resolution of current challenges in the field. In paper restoration, they are used for a variety of processes, including deacidification, straightening, consolidation, and cleaning. The application of nanofilms as a material for the restoration of tracing paper and other transparent thin bases is particularly promising. It provides conservators with new possibilities in situations where the issue of where the use of Japanese paper doesn't yield the desired results. Nanofilms are stable materials made from pure cellulose with variable pH, allowing for the creation of nearly invisible restoration reinforcement. When using nanopaper in restoration, different types of adhesive can be employed. This allows for the selection of adhesives according to the individual characteristics of the artwork, thereby achieving improved restoration outcomes. And in the end, I would like to ask if you have some issues or challenges with tracing paper, transparent paper, please contact with us. It's a very necessary topic for me, and I will be happy to collect and know as much challenges as you give me. And if you have some experience with nanofilms, it will be nice to hear your feedback. Thank you.
Thank you. Very thorough overview and very interesting topic. Do we have any questions? No? I don't know how much practical conservation you do yourself. You do. Do you use nanofilms?
Yes. So I use now. I have practical experience for 17 years. So I think it's quite good time. And I was work with tracing paper previously as well. If to speak about nanofilms, it's quite complicated because I do research of these materials in frame of my PhD work. And in this case, I need to, for sure, I have done some tests, not only in my university or my work, but also in archives in London. They use this technique as well. But because this is scientific research, for me it's necessary to do as much as possible research, and then I can apply it to the real art objects. So now we work with the samples and do different tests. And also necessary moment, this is the way of preparation of nanofilms, because it's quite complicated now. It took a bit of time. You need some equipment, and also you need to have some experience to prepare it nice way. So in this case now we try to work to find the method how to prepare even nano paper to make it much better to use for conservators in practical daily life.
Yeah, we'll wait for that result. Also, another question, would it be, I don't know, in a far future that it's not like a film, that is something that you apply, I don't know, with a brush or something, that it would be easier directly to the tear, this kind of nanocellulose material or something else, like in the future, that the tears would be repaired completely differently?
It could be, with tracing paper, there is a big challenge. Actually, I think that paper conservators do know that some type of tracing paper are very sensitive to moisture. So in this case, it is nice to find some solutions where we can work without application of moisture at all. And for example, sometimes I can show the picture. This is one of the experience of work which I have made conservation treatment. This is the letter from time capsule, and it was made right by iron gallic ink as well. So, and paper was in very bad condition. This was parchment paper, and it was very very dry. So it was like hard to take in hands. And in this case, it's really nice to have different diversity of techniques and materials which are approved scientifically that conservators can use and apply to make their life better and to prolong life of the objects.
Yeah, this is what we need, exactly. Thank you very much.
Thank you.
More questions? Were there any other questions? No? Yes? Comments? Okay. Then thank you once more.
Thank you very much.